I am Karthik of Priorities Fruit Pellet, which is a vision guided autonomous fruit plucking project. Fruit Pellet is a transforming fruit harvesting through advanced dry and drone technology. Our vision guided drones use YOLO based object detection to enhance efficiency and crop harvest. Fruit Pellet is poised to address critical issues facing the agriculture sector, including rising labor cost, quality inconsistency, and labor shortages. We have successfully developed a working prototype and demo for this. The project has successfully reached a fully prototype stage, demonstrating an autonomous fruit plucking system using a drone. This system integrates real-time food detection, autonomous navigation, and a comprehensive web-based monitoring dashboard, which detects ripe foods in real time using onboard computer vision. It also navigates autonomously using mission planner plus drone kit. It also displays real-time system state detections and telemetry on a web-based dashboard. So here you can see the code snippets of the project. We used a YOLO version 8 for the food detection, which is installed on Jetson Nano. For food detection, the project utilizes YOLO version 8 as a state-of-the-art real-time object detection model known for its high accuracy and speed. We also use Mission Planner. Mission Planner helps in uploading autonomous waypoints, setting flight parameters, and visualizing telemetry data, making it an essential tool for both development and field testing of the drone navigation system. We also developed a web dashboard, which uses real-time monitoring interface displaying system. On to the next slide. Here you can see the Mission Planner. Here you can also see the mango getting detected. The drone rotates to the side at which the mango is getting detected. This is how mission planner works. The main key learnings of the project are real-time vision plus hardware sync is challenging, requires optimization and threading. The model accuracy is highly environment independent, lighting and accuracy matter. Deployment on edge devices, for example Jetson Nano, needs model compression and optimization. Simulation first approach help to reduce real-world trial and error. The difference between our first milestone and second milestone is we delivered all the successfully met all promises from milestone 1. Autonomous navigation confirmed. Drone navigation autonomously as planned. Object detection validated. Accurate food identification demonstrated. Web dashboard for monitoring. Developed a functional web dashboard. This is our second milestone achievement. The challenges and hurdles we faced while doing this project are data imbalance, address YOLO training bias from imbalanced datasets through strategic augmentation, telemetry sync delays, optimized mission planner telemetry synchronization to ensure real-time data flow. We also face the challenge of precise positioning, required high precision for fruit plucking. Bounding box also is a very challenging to GPS, which requiring custom geometry. Why we choose YOLO version 8? The speed and accuracy were very good. Offers optimal balance of for small object detection, which is crucial for real-time fruit packing. Easy transfer learning facilitates efficient training with a custom fruit dataset. Active community and optimization benefits from continuous architectural improvements and strong community support. Thank you. Now I'm going to show how we detect how a model works for mango detection.